Next, we're going to talk about finding limits of summation formulas. So in example 5, we're asked to find the limit of s of n where n goes to infinity. Alright, so the first thing we want to do is actually multiply this out. And hopefully you can recognize that this is one of our summation formulas. It's actually the summation formula for I squared. So if we go back and look, you can see here summation of I squared is n times n plus 1 times 2n plus 1 over 6, which goes to 2n cubed plus 3n squared plus n over 6. Okay, so we're going to use that here. And so if we want to find the limit as n goes to infinity of 42 over n cubed, and this is going to be 2n cubed plus 3n squared plus n over 6. Okay, so here we're finding the limit of this. Now we could multiply this out, but what I want you to notice here is that we're going to infinity, and we also have an exponent of 3 on top and an exponent of 3 on the bottom. So this is what we remember from first semester as eats dc. So if the exponents are the same, then divide the coefficients when you're finding the limit as n goes to infinity. So what we're going to be left with here is our 42 on the outside will keep, and then times 2 over 6. Okay, and this is going to be 42 over 6 is 7, so it's 7 times 2, which is 14. Okay, I want you to try letter B on your own, and go ahead and pause the video and then come on back to check your work. Alright, so after you multiply here, you can see that the exponents are the same, so the limit is going to be the division of the coefficients, so it's going to be 1/3 times 1/2 or 1/6. Now in example 6, we're asked to find a formula for the sum of n terms, and then use the formula to find the limit as n goes to infinity. So here we can see the limit as n goes to infinity of the sum from 1 to n of 3i over n squared. Well, what we want to do here is, if we can, go ahead and factor out our constant here. So we have the limit as n goes to infinity of 3 over n squared, and then times the sum of from I equals 1 to n of I. Now what we did in that step is it's helping us to find our formula, because we have the formula for I, and so this is going to be the limit as n goes to infinity of 3 over n squared times, and then our formula here is going to be n squared plus n over 2. And now this problem looks very similar to the ones that we just did. When you look, you can see that your exponents are the same. And so we're just going to end up dividing these coefficients, and we're going to get 3/2. Okay, so if you're going to find the limit as n goes to infinity of a sum, you're going to go ahead and try to factor out your constants so that you can use one of our formulas. And then once you have that formula, decide how to take the limit using Bobo-Botten eats dc. Alright, let's go ahead and try B together, since this one's quite a bit more difficult than this one. We do want to follow the same steps that we've been following, and whenever you're confronted with something that looks like this, we want to try to get rid of our squares and see if we can't write this as a polynomial first. Okay, so let's see if we can write this as a polynomial. So we're just going to be dealing with this part for now. So let's go ahead and square that, and that's going to be 1 squared plus 2 times 1 times 3i over n plus 3i over n squared, and then all of that is times 2 over n. Okay, so that was just squaring a binomial right there. Let's go ahead and simplify this a little bit. So this is going to be 1 plus, let's see, 2 times 1 times 3 is going to give me 6i over n. And then here, if we square this, that's going to give me 9i squared over n squared. And then this is all still multiplied by 2 over n. Now, it's still not quite in a polynomial form because we still have this multiplication. So let's go ahead and distribute this here. So we're going to get 2 over n plus 12i over n squared plus 18i squared over n cubed. Okay, so once we have a polynomial, let's go ahead and rewrite our sum and our limit formula here. So this is the sum. So I goes from 1 to n, and it's the limit as n goes to infinity. Okay, so we're going to just do this all at once. We've had a little bit of practice with finding this sum. So here you can see this is just a constant, and so our formula here is just going to be 2 over n times n. Okay, here we have a constant times I, so it's going to be that constant times n squared plus n over 2 from our summation formula. And here we have a constant times I squared. So that's going to give me 18 over n cubed times, well, I squared is 2n cubed plus 3n squared plus n over 6. Okay, and all of this we're finding the limit as n goes to infinity. Okay, so for each one of these terms now, you can use Bobo-Botten eats DC to figure out what we have going on here. So looking at this one, I can see my n's are going to cancel, so the limit is going to be 2. Okay, here the exponents are the same, and so we're going to get 12 over 2 or 6. Okay, here we can also see the exponents are the same, so we're going to get 18 times 2 over 6. Well, 18 over 6 is 3 times 2 is also 6, and so this limit is going to equal 14. So that's how we can find the limit as n goes to infinity of our different summation notation formulas.